Got a 2002 Honda Accord. It's got 2.3 VTEC. This car, of course, came from the dealer. The guy that's selling cars from the auction, and mind you, every time I get a car from him, it's like always an interesting backstory, something interesting. So I'm gonna cut the car down for a second, and we'll look at freeze frame data and give you the basics of what's going on with it, and we'll go ahead and tackle this issue, get this resolved, and out the door. I'm gonna go ahead and pull codes. I'm in the generic feature only because in the bidirectional portion, I didn't have the same information, and I didn't have as much PID data for bank 2. So some cars are better than others with the all-tail, but I'm gonna stay in the generic portion here. The code that came up was dealing with the heating circuit for the downstream. From what I understand, the car catalytic converter was stolen, so they put an aftermarket one on here with the aftermarket sensor. The aftermarket sensor has the Bosch shape. It's a Bosch sensor, and if I recall, Denso is what goes on here, if I recall properly. Yeah, I think Denso. So this is the code P0141 O2 sensor circuit, bank 1, sensor 2. So that's basically stating, oh, hey, all right. So that code is basically stating that there was incorrect voltage during startup or after a certain amount of time. I think it was like after 80 seconds after startup, it was determined that there was incorrect voltage. So the sensor should be oscillating between, it shouldn't be oscillating, but this is an oxygen sensor, so it should be between 100 millivolts and 900 millivolts. So unfortunately, it determined that there was higher than normal voltage, and that's how we determined that there was a fault with the sensor here. So let's see what we got. If we look at the freeze frame data, so I can get zoomed in here, it doesn't show much as far as the running conditions of what happened, and it doesn't give me downstream information, and it's generally pretty useless for the catalyst issue. But if it was something more related to the primary upstream, this would be a lot more help or informative. But this from what I observe, this is really not going to help me out to a degree, sorta. But what happened? The fuel system status was an open loop. So the oxygen sensor heater went through its monitoring phase in an open loop status. So again, if it's running after 80 seconds, it would, depending on the conditions or the temperatures for the monitors, it's going to go through its testing phase. Typically, drive cycles with oxygen sensors, normally your temperatures ideally want to be below 90 degrees on the coolant temperature and the air intake temperature. So if you look at the PID data, your intake temp sensor is below 90, the coolant temp sensor is below 90, and they're within 15 degrees of each other. The car is ready to go through the catalyst monitor, evap, and heater monitor circuit testing. So just FYI. So this went through a check phase in open status, or determined there was a fault in open loop status. So the coolant was below 180 degrees, and we got 140 here. So open loop fuel system status. The car has been running that long. Calculated load value is 41%. So it's a possibility, being that it's an open loop, that it was probably still warming up. Engine coolant temperature is 140. Short term fuel trim was at -7, which is taking away 7%. Long term is taking away -2. Again, the car was not in closed loop status. Intake manifold pressure was 6.9 psi. So what's in vacuum, 14 psi is going to be the static, or I guess it would be the stoichiometric of manifold pressure sensors. Since atmospheric pressure is 14 psi, this is just an interpretation. RPM 1100, so it seemed like we're just at idle, no speed. Intake air temperature sensor was at 120, so the car seemed like it was just either driving, came to a stop, and was still in the transition of warming up, going to closed loop. because throttle position is at 9% here. So the only thing this really does help and tell me is that being that the short term is taking away -7%, the long term is not pegged out, so there's no way it could really have a direct or significant influence on downstream sensors. So with -2%, so that's nothing. That's really insignificant. So despite it being a heater circuit, I don't think this car is intelligent enough to know that there's a fault with the resistance in the heater. I think it only determines a fault based on the initial voltage. So this is just my conjecture, being that the information was very vague in pointing out what's going on with the code setting criteria was very vague. So again, it has to be running more than 80 seconds and determine that it was abnormally high voltage. Okay. And let's go to, so we are in the generic, we are in the generic feature. I'm going to go to live voltage, live data. I'm going to start the car up, monitor the voltage for the short term. We're going to look at temperature, calculate a load, loop status, air intake temperature sensor, since we had that PID. We're going to look at the voltage here, and I don't know if you see there's a fault here. I do have that sensor plugged in, but that typical voltage there is normally when it's unplugged, so keep that in mind. And we're going to pull those up. Let's start the car up and look at data. Alright, just in case anyone's wondering, the sensor, I took the intake tube off. It's going to be down there. So I get my light on. Here's my sensor for my downstream here. There's the harness. So if I need to do any testing, there's a connector I just broke off right there. Just a tab that's holding it. You can follow that and you'll see where it's supported. You can see it right there. And I'll just bring it through those air conditioning lines and up if I need to test it. But I don't think that's going to be our problem. I think this is simply just a bad O2 sensor, honestly. But let's look at it, and we'll do some basic tests and see if we can conclude that this oxygen sensor is bad and replace it. Alright, number one thing here, since we still have high voltage on bank 2, on our sensor 2 here, I'm going to mess with that connector first and see if there's probably a connection problem, see if that voltage changed. And if there is, then I'm going to check the connector. There was no change. Another thing I'm going to do, simply just disconnect it. I could hook up on the signal side of the actual sensor and monitor the output from there, because it could just be an issue between the connector on back. And again, if somebody stole the converter, they probably could pull wires out. So it would be a wise decision just to pull the connector off, do some simple like resistance tests, see if we get some type of backfeed, or like a simple voltage test on the heating circuit, signal circuit, and see what happens. But I'm going to disconnect it first. So I disconnected. There was no change in the voltage. It's still high. Pull the sensor up here. Alright, let's do some quick tests on the sensor and see if our signaling side is working like it's supposed to. So first thing I'm going to do, I got the key on, engine off. I'm going to check my ground here because there's a possibility the sensor might not be pulled to ground. So the ground here, since it's doesn't have ultra low emissions, it's going to be this green and black wire here. And we're going to see if I can get my flick stay put here. Scam phone calls coming in, I tell you. I don't know them fuckers. Alright, so we're going to do ground. I'm going to put my red lead on the negative terminal. Get it to sit there. If it want to cooperate. And do a quick test on the engine. If I got good ground or not. And I don't. Let me go find an alligator clip. Alright, got that. Now, if you don't know about how the oxygen sensors are wired, one thing you can have is one of these universal wiring diagrams here. And I did this on one other video, hooking up a, what was it? I can't remember what the video was, but I know I did one, but this is why I got this. So we can look at the wiring and get an idea where we need to be, but I'm not using this. I'm using wiring diagram, but if you don't, it's not a bad idea if you're just like an introductory to dealing with oxygen sensors and wiring integrity. So you can, like, say for example, where am I? I know it's a green, so our green here is going to be ground, and that's where I'm going. So this does reflect ground here, so it is multifaceted and accurate with general vehicles. So alright, moving on. So we got good ground. Should be lower than that. Why isn't it lower? I need like 2 ohms or 1 ohm or something. Probably because the throttle body probably isn't the best ground. Yeah. Nope. Let me switch them. And I'm pretty sure it has a lot to do with the yeah, they're different. I'm pretty sure it has a lot to do with my ground here. The car might not be that great with the ground straps, but that's still low enough to be able to hold some amp draw. So I'm gonna leave that where it is. If it'll support my test light, I'm not gonna question it. So alright, so here we're going on the green and black down at the bottom here. We got 14 ohms. The problem is, you know, I would like ideally for my ground to be a lot lower than that. Let's see here if I move it around. And what I could do, test the front. You know, see if the front has the same type of resistance value. And since the front is real accessible, I'm going to reach around here, pull this front one off, and go to the same color, black and green. And we're going to see that reflect down the bottom left of the screen here once I find it. So we're hooked up, so it does have the same resistance value, 14 ohms. Alright, no big deal, because we know our front one, our upstream works. Now that will generally work for O2 sensors. I don't know about wideband, but we're testing a simple narrowband circuit here. Now, just for the sake of it, I am going to do a load test. Put my test light on positive, go to my green and black, and see if it'll support a load here, and it does. So my test light is lighting up. So it's no big deal. So let's go to the sensor circuit side. So we're going to go to the signal side, which is going to be the white wire. Now I'm just going to test the front one here, the bank 1 sensor 1 wire. And I'm just gonna I'm just gonna just get a voltage signal. I mean, just the regular back feed or whatever is producing, and get an idea of what the front one or the rear is expected to have. So I'm testing the white wire, and I'm just on direct voltage. It's pulling, it's producing 400 millivolts. I'm simply just going to do the same with the other white wire here, just to get a general idea. And I'm just doing a comparison. Where's that white wire? There it go, right there. So here's our, looking at the connector. White wire is gonna be right there. So I'm gonna move it around. Despite it being a little less, so it's still really close to where the front one is. So, and I'm just gonna move it around, make sure there's no issues with connection. Despite it fluctuating. I'm gonna move around with the connector. If I can get myself straight, I'm just gonna move it. All right. I don't know what that is. Despite the little movement we have, it's not enough to be a problem. And this is me not being able to keep that connection steady. So we're good on that one. All right, so our signal is supposedly fine. I'm going to go to my heater, which is the 12-volt circuit, directly behind that. So here's our 12 volts. We got 11.8, which is good enough for me. And can it support a load? My test light is already hooked on ground. Yes, it can. So we got good ground. We tested that, supporting a load. We have this compatible 400 millivolts on the signal side. We have 12 volts on the heater circuit, and the only other one I didn't test was the black and white, which was the heater control circuit. So if we might as well do a quick test on that. There's our black and white sitting. All right, so we're gonna test the control side of the heater circuit, and I'm just gonna compare the heater control to the front to the back. Being that it's a switching circuit, normally being it's the ground side switch for it, I'm going to just do a resistance test and test it that way. And I'm just gonna go to ground, pull my connector for the sensor one, go to my black and white wire, do a resistance test. On there. Make sure my connection's good here. Alright, I had them hooked up backwards. So I got my positive on negative, and I'm getting a 209 k ohm reading. So I'm just simply gonna do the same for the front here. For the rear, the downstream, and find my black. Find my black and white. Here we go. 210 k ohm. So they're within 5% or so. So we're good. I think that sensor's just bad, man. Just simply put, I don't want to. There's no issue with the wires being pulled or anything. They were compatible with the upstream. The sensor's just not working. So what I'll do, just to make sure there's no connector problem, try to hook up to the signal side and pull the signaling side down, and we'll see if it reflects in the PCM. if it do, I'm just going to simply replace that oxygen sensor on the downstream here. That'll be good. Just gonna keep this simple. I'm gonna take a. All right, let's try this again. My phone shouldn't be ringing, but I'm hooked up on the black wire for the unit. This is a universal biosensor. The black wire is going to correspond with the red and white wire that is going to the signaling side of the PCM. And strangely now, if we look at live data on the sensor 2 side, since I hooked it back up, we got 300 millivolts, and it is reflecting here on the Fluke multimeter also. So I'm going to start up, let it go into closed loop, and see if we have some oscillation or any type of flat line or any type of spikes, or we'll see if we'll look for any discrepancies with the sensor voltage once it's running in a closed loop. Alright, so right now, since we got the car running, we should be in closed loop now, since the bank 1, sensor 1 is starting to oscillate, and downstream 2 is stuck at 350 millivolts. So before it was stuck at 1.2 volts, now it dropped down to 300 millivolts. Not sure why, but if I can get it to work, it may have seemed like it was probably a connection problem with this sensor. But despite me connecting and reconnecting it several times, you know, it could just be something that's intermittently going out under certain conditions inside the sensor. Not sure yet. But I'm going to monitor this for a little while and give it gas, rev it up, maybe add a little fuel to it and see if it changes downstream. But currently it's working normal. This is how the downstream sensor is supposed to operate. So I'm going to let it do its thing right now and wait on it to have some faults. Now, what I could do, like I was saying earlier, see if I can pull the sensor down. I do have my test light here, and this is going to be my bias, my high resistance ground here. So this is the safest method of pulling anything to ground or supplying power. So I'm going to, since we have the reflection of the sensor voltage here, this test light is grounded. I'm simply going to place my piercing in on the alligator clamp that's connected to my signal wire, and the voltage should drop. And yeah, so what that means is that we're capable of controlling the side. We can bring it down to ground. Also, if I can hold that camera and touch the positive side, I can also bring the voltage up. Hold on one second. So I'm going to touch the positive side of the battery. I'm going to be the resistor, and the sensor should be drawn up in battery voltage. I think it came off. So all right, so this is our current voltage. I'm going to grab one in here. I'm gonna see if I don't know if I can get everything on camera. I think we'll be fine with this. So my fingers are going to touch the positive side. Now I'm going to touch the input side of the sensor here, and we brought the voltage up. I'm going to let off of it. It went back down. I'm going to touch it again, and I'm simply bringing the voltage up. So I can control that, and just show you what it looks like. I'm grabbing it. The voltage is climbing, and it drops. So that's one quick way of testing the signal side. I should also be able to ground it by grounding myself. And grabbing the input side, but unfortunately that's not working the same, probably because I could be getting some interference from the ignition system. That's why we have noise reducers and stuff on the engine. So it did reflect pulling it to ground. It did reflect pulling it to high voltage. So strangely, the sensor's working fine. One other thing I can do is administer some fuel in the intake and see if it produces a richer condition. Alright, I don't have any propane, so I'm going to use my MAP gas here. And it should make the downstream sensor rich. I am now administering MAP gas. So if low is lean, this should go up to, you know, like 400, 500 millivolts. And I'm going to look at the upstream sensor here, and my upstream sensor is currently almost pegged out. It's at 900 millivolts. The downstream is not reflecting, and it could be a couple reasons. Probably because not a significant amount of fuel, because the catalyst is a furnace and it's supposed to burn off these noxious emissions. Let me give it a little gas. I'm going to try to force it richer by adding brake cleaner and seeing if that will cause the downstream sensor to reflect also. Alright, pardon me. Let's see if I can get in here. Alright, so it's still stuck at 350 millivolts, 360 millivolts. So this sensor shot. I mean, now the short-term fuel trims are taking away 14% because it's trying to compensate for those rich conditions. The initial fuel trims are lean. As a result, this is stuck. I'm going to replace this oxygen sensor on bank 2, and we should be good to go. Let's do one more test here. I want to pull the sensor out and simply do a resistance test from the connector down to the head of the sensor, or I guess it'll be the depending on how you're looking at it, where the wires go into the sensor. So I'm gonna pull the sensor out, we'll do a quick resistance test, and I think that will conclude the sensor is actually defective. Because if not, we can repair that broken wire and still use the old sensor. It's brand new, so let's see what happens. And I'm only doing this because, well, for one, just to confirm that we are 100% sure that this is bad, and then two, when I got moving the wire, it did start changing the numbers on the scan tool, going up to like 400 millivolts at times. So why not? All right, let's try an alternative route, because the last one wasn't cooperating. So we're going to go into black right here. Put our alligator clip, the black there. Let that rest somewhere. Here. And I'm going to go back there. We're going to carry on our resistance test. Alright, so let's get a good spot. I was killing this wire. Move it around. Damn it, what is hot? So I got a new sensor. Got a Denso from O'Reilly's. And here's the part number if anybody gives two shits. So I'm gonna really quick, I'm just curious, I'm gonna test the heating circuit with this new one and compare it to the old one, just for my knowledge, and get this installed. Let's take a look at the old one though. Like I said, it was brand new. It's got a new connector. That was from me beating on a damn thing. So the connector's new. We see some obvious differences. This is a Bosch, this is a Denso, and we see the structural differences. The body's more slender, the head of it's different where it retrieves a signal, gets on the side versus on the head of it. Alright, let's get our ohm meter. We got a mess, man, I'm gonna tell you that. We got a lot of wires everywhere. Alright, we're gonna test the heating circuit. So we're going to test the resistance of the heating circuit. The heating circuit is going to consist of, they're going to have the same color coded wires. Like on this Bosch here, they're going to be white. On the Denso, both of them are going to be black. Alright, so I got my tester on resistance, the little horseshoe thingamabob, and we're just going to simply pierce those two wires with the opposite piercing ends and get a value. Let's see what this one is. We got... How's it doing it? Just jumping everywhere. It's weird, just jumping everywhere. Wasn't steady. Alright, so we got let's see, 3.5 ohms with the Bosch. Oh shit. I don't think it matters, it's going in the garbage anyway. And the two black wires on the Denso, we have a value of 16 ohms. Yeah, 16.1 ohms. Cool. So, new sensor versus old. So I want to get this installed. We'll look at the data, conclude the video, and go on to the next one. See you in a second. Alright, we got a new sensor in there. I'm just going to try to get connected really quick. Didn't take but like 90 seconds to get that sensor installed. I'm not going to clear the code yet, but we're just going to look at live data and to confirm the fix. Before, it was basically an open circuit, standing at 1.2 volts. After testing, some strange reason, the voltage dropped to 350 millivolts. If this don't work, I'm quitting and going to Family Dollar, so be prepared for Family Dollar uploads. So here we go. So we haven't really entered closed loop yet, so I'm going to let the sensor warm up. Let me look at the temperature. So we are in closed loop. I'm just going to give it a second for it to get hot. Yep, there we go. We're dropping. There it goes. Let's look at the graph. That was nice. It was a nice slow slant. Look at that. We got operation. And it should reflect the upstream here also. Let me merge these graphs here. Bam. Bam. So our green is going to be sensor 2. Before it was stuck up at 1.2 volts. Now we have somewhat of oscillation, but steady, slow reading like a post-cat sensor is supposed to. For the most part, the frequency is 60% less oscillation than the upstream, and it's nearly flatlining. So this is great. This is still really good, and it's reflecting our initial readings here. So it's, again, once it gets hot, it's going to become a lot more steady. But being that the sensor's new, the car was off for a little bit, that converter needs to be good and warm. So this is fixed. It's reflective of the initial reading. So again, the catalyst purpose is to get hot, burn off those rich mixtures, those noxious emissions, and basically keep that oscillation that we see from the initial balance of trying to keep everything settled steady. So we see the downstream stabilized in comparison to the rich and lean oscillation of the pre-cat sensor, if that makes sense. So this is good. Again, when you have a rich running condition, that catalytic converter is supposed to burn all that stuff off and make it into a leaner mixture, and it's doing its job right now. So low is lean, high is rich when it comes to an oxygen sensor. We don't have any oscillation on the post-cat sensor. We do with the pre-cat, which is normal. The post-cat is working like it's supposed to. It's great. So now the ultimate test obviously will be driving under load conditions and seeing if it could stabilize its voltage while at highway speeds. So The cat is pretty new, so it wouldn't surprise me if it does or it doesn't work, but I'm pretty sure we'll be good with this new cat here. The wheels are great. There don't seem to be any exhaust leaks. It wasn't any issue on their part. Obviously, on installation, it was just a defective part. It's a Bosch sensor, aftermarket. Things happen. People can question the quality of it. You know, it don't belong in this car. Things go bad. You know, so what can we do about it? But other than that, hey, this car is fixed. We didn't have oscillation before. We have readings now. We went through a full test of how to test oxygen sensors. Hopefully some people learned some things new. You know, you can be the resistor, pull that sensor to the ground. You can increase the voltage, see if it reflects with the sensor signaling or input, PCM inputs, and should be good to go. But you know, there's 1,000 videos on this. Yo, this, I don't know. Hopefully it should have been something a little different. But other than that, look, hit that link, subscribe to the channel, stay informed, have that reassurance in my work. See you on the next one.